Okay, you're asked to evaluate this indefinite integral using trig substitution. When you use trig substitution, you want to use either sine, secant, or tangent of theta. And the fact that this is a plus sign tells you that the square roots of those terms will be the legs of the right triangle. And since we want the variable to be in the numerator of the tangent of the trig ratio, so that's where we put the legs. 5x over 2 is the tangent of theta, and the hypotenuse would be the square root of 25x squared plus 4. So everything in blue is what you need to do to complete the trig substitution. So the tangent of theta equals 5/2 x. That means theta is equal to the inverse tangent of 5/2 x. We might not have to use that, but write it down anyway. Solve for x, and we get x equals 2/5 tangent theta. So dx is 2/5 secant squared theta d theta. Now we'd like to come up with an expression for this denominator in terms of theta. So we know that the square root of 25x squared plus 4, x is 2/5 tangent theta. When I put that in there for x and square it, here's what happens. We end up with 2 secant theta. But we don't have the square root of 25x squared. We have plus 4. We have that binomial squared. So that's the same thing as the radical raised to the 4th power. But we know that the square root of 25x squared plus 4 is 2 secant theta. So there is an expression for the denominator. Now we're ready to do the trig substitution. dx is 2/5 tangent theta, where did I get that? It's dx is 2/5 secant squared theta, d theta, and the denominator is 16 secant 4th theta. And when you simplify that, you end up with this. We're ready to find the antiderivative of cosine squared theta. I won't go through the derivation of defining the antiderivative for that. It's in a table of integrals for sure. It's 1/2 theta plus 1/4 sine of 2 theta. If I distribute the 1/40th, I get this, but I can also use the trig identity to sine it twice an angle as 2 sine theta cosine theta. Now we're ready to replace theta. So theta, well, we did have to use this inverse tangent of 5/2 x plus, you can see that 2 goes into 160 80 times. The sine of theta, look at your right triangle, opposite over hypotenuse, 25 over the square root times the cosine adjacent over hypotenuse. And 5 times 2 is 10. 10 goes into 80, 8 times. We're left with 8. And this radical times itself is just what's under the radical. Finally, I added the plus c. That's your antiderivative. Here's sort of proof in Desmos. Here's the original function in blue. Here's the antiderivative that I got, big F, this curve in red. And when I take the derivative of big F, that's f prime of x, these two graphs are identical. So that kind of proves that indeed that is the antiderivative for little f. Okay, there you go. Hope that helped. If you have any questions, post a comment.